Hello guys, welcome to a new video, and in this video we are going to be configuring NAT, and NAT stands for Network Address Translation, which is a feature of the firewall that you can do either with IPv4 or IPv6 just to add basically more security. You can enable NAT for all the dashboard objects to help manage the network traffic, and also because you guys know that we cannot route the private IP addresses like 10.1.1.2. It's a private IP address. 10.1.2.1 it's also a private IP address. So we cannot route those private IP address to the public network. We need to use a public IP address to be able to send it to the outside network. And NAT came to the rescue because we were the IPv4 addresses were running out, so they came out with this new it was a long time ago that they came out with NAT, so we can save more and more IP addresses, IPv4 addresses. We have saved some more that we were supposed to be run out like 10 years ago, and we are still haven't run out of IPv4 addresses because of NAT. So if you want to learn more about NAT, you can also go ahead and do a Google search of NAT, and you're going to be able to see what NAT is all about. But from the CheckPoint, we are able to do a couple of different network address translation. One is a static NAT, which is each internal IP address is translated to a different public address. So if we take, for example, if we have 10.1.2.1, it's going to be translated to 20.1.1.2. And if we have another, let's say another Windows device over here, it is going to be translated not to this one, but to another public IP address. So it is basically a static NAT. It's basically a one-to-one translation. And then we have the hide NAT in CheckPoint, and it's the firewall uses port numbers to translate all internal IP addresses to a single public IP address. So if we have like 500 Windows devices or devices in the local network, we were going to be use this single public IP address and just add a port number at the end, so we are able to identify where the traffic is coming from, right? So if it's coming from Windows device 2, then it was going to add 20.1.1.2:2, so we can know where the traffic is coming from. So that is hide NAT. So HIDE, hide NAT. And then we also have what is called the hide NAT with port translation, and use one IP address and let external users access multiple application servers in a hidden network. So either FTP port 21, SMTP server port 25, or an HTTP server port 80. So basically, if somebody from the outside tries to reach 20.1.1.2 at port 80, then that's going to get routed to a server that does HTTP. So we are going to be doing that on a later video, but in this video what we want to do is we want to do a hide NAT. So we are going to be translated 10.1.2.0 network to another IP address. We're not going to use this IP, we are going to just create another one, and we are going to be using 20.1.1.4 public network. So let's go ahead and duplicate this bad boy in here, and if we can go ahead and move it around, move it, there we go, put it over here, change that and say that 4, and we are going to say that it is NAT, network address translation. Great. So what we want to do first is that we want to go to our Windows device on 10.1.1.1, and we want to go into the Smart Console. So we want to go ahead and log in if you haven't yet, and then after that, one thing that you need to verify is that the CheckPoint firewalls are allowing ping, because we're going to be pinging these firewalls. So one way to do that is by, if you go to this top left and you go to global properties applies to every single one of the firewalls. So from here you go to firewall properties, and if you go down and you can see right here, accept ICMP request, make sure that it is at least first or before the last. If it is last, it won't be applied. And also you need to make sure that you are logging the implied rules. If you're not logging the implied rules, then you won't be able to see it from the log monitor. And then if the Smart Console is not saying that you allow ICMP, make sure that you check that, and press OK. And then after you press OK, what you want to do is you want to go ahead and install the policy in both CheckPoint firewalls. So just do that for me, please, if you haven't done so. But if you have it configured, like I have it configured, let's go ahead and start with this. So the first thing that we want to do is that we want to create a object for 10.1.2.1. Okay, so we are going to be creating an object for this side, and then we are going to tell it that we want to translate to 20.1.1.4. But before we do that, we want to see how it is being done right now. The way that is the way that CheckPoint, or the way that this Windows device is going out to 20.1.1.1 is by using the 10.1.2.1 IP address, which is a private IP address, and we do not route private IP address to the internet, right? That is not possible. That's not how it is done in real life. So we want to change that. But before we change that, we want to go ahead and see if it's actually happening. So we want to go to this Windows device over here, and we are going to do an ICMP. So we are going to go to the command prompt, and we are going to ping 20.1.1.1. Pint, it's not pint, it's PING. So there we go. We are pinging 20.1.1.1, and we are getting a reply. That is great. So now let's go ahead and go to this Windows device where we have the Smart Console, and we want to go ahead and go to logs and monitor. And from over here, we are going to see that we are getting a source of 10.1.2.1, and we are getting an echo request ICMP, and you can see that is coming to the destination of 20.1.1.1. So we are pinging from this device to this CheckPoint firewall, and it is allowing it through this firewall, and this one it has allowed ping. That's why we are able to get that echo request. So now you can see it in the log as well, 10.1.2.1. If you go ahead and double click on it, you can see the origin, the CheckPoint gateway 1. It was today. It was a firewall access connection. It is coming from 10.1.2.1. So we don't want that to happen, because in real life that's not how it happens. In real life, we are doing a NAT translation to that public IP address, which we're going to be doing, and you don't see any NAT related details in here. So what we're going to be doing is we are going to be configuring NAT, and then we're going to ping again, and you guys are going to see that the NAT translation is actually happening. So from here, or from anywhere that you are, you can either go ahead and go over here and create a new network, or you can also go to objects over here and create a new network. And the network, I'm going to call it, let's say, gateway 2 LAN network. So LAN network, and that gateway 2 local area network is at 10.1. What is it at 2.0? Net mask is /24, so 255.255.255.0. And that's how it is. So 10.1.2.1, 10.1.2.1, correct? That is correct. Or 10.1.2.0, that is a network. And then we want to go ahead and go to NAT. So here's what everything happens. So what we want to do is we want to go ahead and check add automatic address translation rules. So what we want to do is we want to go ahead and go to the translation method, which is hide. Hide, like I said before, it is basically the dynamic NAT, which is the PAT or the dynamic NAT. So we are going to select NAT. If you do static, it's 1-to-1 mapping. If you do hide, it's from one to multiple to one translation, right? One to many. Okay, so then what we want to do after that is you can either do hide behind the gateway, which means that we are going to be using the CheckPoint gateway public IP address, which is 20.1.1.2, but we don't want that. We want to use 20.1.1.4, which is available for us. So let's go ahead and do hide behind this IP address 20.1.1.4. Where do you want to install this? Make sure that you do this. You will want to install it only on CheckPoint gateway number 2. And I still haven't changed it, but yours should say number 2, and there we go. Then we are going to select press OK. After we do that, you can see it over here. Now if we go to the security policies, and then we go to the NAT policies, what we are going to be doing is we are going to, let's go ahead and publish our configuration, publish it, so we can save our configuration. And then what we are going to be doing is that we are going to, and you can see that that translation over here. You can see that we have a G2, it is the gateway to local area network, and you can see it's 10.1.2.0 network, and it's going to be any original destination to any original services. And you can see H over here, and the H indicates that we're doing NAT hide, right? We're using hide or hide NAT, so we're doing that dynamic NAT, right? So that means that it is going to be translated into it doesn't really show you over here. Yep, it doesn't really show you, but it's going to be translated with hide NAT, and that IP address that we gave it was 20.1.1.4. So let's go ahead and install the policy. And where do we want to install this? We want to only install it on gateway number 2, because that is the only one that is going to be using it. So let's go ahead and do that. And we can see it over here, the policy has been successfully installed. So that is great. So what we want to do is we want to go ahead and logs and monitor, and we want to go to this PC over here. And what is going to happen is that whenever I ping this from this computer to the outside, so going to the outside, it is going to translate my 10.1.2.1 into 20.1.1.4 hide NAT. And there, and this checkpoint firewall is going to receive it as 20.1.1.4. So let's go ahead and ping from this computer, Windows 2. Let's go ahead and do another ping. We are getting those replies. Let's go ahead and go back to the checkpoint, and let's go ahead and go to logs and monitor, and we are going to refresh it. And when we refresh it, you can see now that we have a source of 20.1.1.4. Remember that before, whenever we did that ping, we got that IP address of, where is it? We got that IP address over here of 10.1.2.1, which is a private IP address, and we don't want to do that because it is not going to allow you. Basically, you cannot do that in the real life. But if you go ahead and double click on the one that we just did, 20.1.1.4 now, right click on it, let's go ahead and open it, and now you are going to see over here what we are doing. You can see that the source is 20.1.1.4. You can see that the checkpoint gateway number 1 was the destination. You can see that it was the echo request ICMP. You can see which interface it came on, and all that good stuff. Let's go ahead and, can we do more? No, we cannot do more over here. So that is good. But as you can see, we were able to successfully configure hide NAT. Hello guys, welcome to a new video, and in this video we are going to go over static NAT. Remember, static NAT is a one-to-one mapping. On the previous video, what we did was basically a hide NAT. That's what they call it in CheckPoint, but it's basically a dynamic NAT where we took all the IP addresses on this local area network, which is 10.1.2.0 network /24, and we added it to this NAT's public IP address 20.1.1.4. So everybody on this network right now is only one device. Whenever they go out to the internet, it is going to go out using the 20.1.1.4 IP address. So now we are now routing this private network. We are actually going out with the 20.1.1.4. So we did that. So on this video, what we need to do is that we are going to create a static NAT, which is a one-to-one mapping. So we are going to add a server, a Linux server that I already added to my EVNG, and I'm going to show you where you need to go for you to be able to add this Linux device. So you're going to go to firewalls-.net, and I am going to add the link on this video. So if you want to go ahead and take a look at that, and so you can add it, and so you can make this static one-to-one mapping network address translation. So I'm going to add it there. So what you need to do is really simple. It's basically what we have been doing, but they are providing the Linux images for you. So what you want to do is you're going to click on the first link that I'm going to add. Then you want to go ahead and download the Linux images here. So the one that you want to is going to take you to this link, and the one that you want to download is the Linux Ubuntu SRV 16.04.4, the webmin. This one's the one that you want to download. Okay, so after you download this, what you want to do is you want to go ahead and log in via SSH to the Google Cloud. After you do that, you want to do a cd opt. So you want to go to this directory. After you go to that directory, you are going to upload the image that you're going to download. This one over here, you're going to go ahead and upload it to this location. Then you're going to go to that location, and then you're going to unzip that uploaded image. Then after that, you're going to remove the raw zipped image file from Eve, and then that's how you do it. And then you're going to, at the end, don't forget to fix the permissions. And then after you do that, the way that you're going to log in over here, they give you the username and password already. So the username and password for this, if you look for it, Linux Ubuntu SRV 16.04.4 webmin is root, and the password is root. And you see that you need 1 CPU and 4 of RAM, and it has only 1 Ethernet. And the way that you access it is via the IP address that you give it, and then the port is 10,000, but we are going to change that port to not have any ports, just because I don't like having that port. Okay, so I already have it uploaded, like I said, and I'm going to go ahead and first we are going to have to stop this switch, and we are going to go to edit this switch. Yeah, let's go ahead and edit that switch, and we need to go ahead and add 2 over here. You're going to have 1, so you want to have 2, so we can have more interfaces, because we didn't have that many. And then after you do that, you're going to go ahead and add the node. After you already upload it and do all these steps, you can go ahead and add that Linux device. You can search for Linux. You can see over here, and you're going to select the Linux Ubuntu SRV 16.04.4 webmin. You can add more CPU if you want to. I'm just going to add 3, so it can be a little bit faster. The RAM is going to be 4. And let's go ahead and VNC is fine. Press OK. So now this one is going to have an IP address of 10.1.1.6. So let's go ahead and put it over here. Let's go ahead and change that IP address to 10.1.1.6. Now let's go ahead and plug this Linux box to the switch. Save it. Looking good. Now let's go ahead and start that Linux device, and let's also go ahead and start that switch. And this one is going to take it's going to take a couple, I think it takes like a minute for it to boot up. So let's go ahead and wait for it. So now what we have to do is we have to go ahead and log in. Root, username and password is the same, root. So the first thing that you want to do is you want to do an ifconfig and see which Ethernet we have to configure. So we need to configure ENS3, and this one is going to have an IP address of 10.1.1.6. So let's go ahead and do ifconfig ENS3. It's going to be 10.1.1.6. Net mask 255.255.255.0 up. Then we are going to do a route, add a default gateway, so we can add a default gateway. Default gateway 10.1.1.3. There we go. So now if we go to the Windows device, we open the browser, whatever browser you have, and if we go to 10.1.1.6, let me close this. There we go. So HTTPS 10.1.1.6. HTTPS 10.1.1.6. And remember, the port number by default is 10,000. So 10,000. There we go. That's going to take you there. So that's the default port. So if you go ahead and continue to this web page, it takes you there. So what I want to do is I want to remove that port number. I don't want that port number. I don't want any port number. So the way that you do that, you want to go in here and you want to do a sudo nano, and you want to go to let's see, a -w etc webmin miniserver.conf, and we want to go ahead and change this port number to nothing. I don't want to have any port numbers. That's how I want it. So let's go ahead and do Control X and Y to save it and press enter. So after you do that, you need to go ahead and restart the webmin, and the way to do that, you do a sudo etc init d and then webmin restart. There we go. So after you restart that web server, if you go back to that Windows device, and this Windows device is in the local area network, they're in the same network, it's this one right here, and that's why it is able to get there right now. So if you go ahead and refresh with port 10,000, you cannot get there. So now what you need to do is you need to go ahead and go to just 10.1.1.6 without the ports. Did it not work? 10.1.1.6. That is not taking me there. Let's go ahead and go to the nano again. The port is nothing. SSL is 1. So 10.1.1.6 HTTPS. So it is now working. Oh, that's because instead of instead of no ports, you need to port 443. That's why. So let's go ahead and do port 443. Control X and yes to save it. Oh, cancel. I pressed the wrong one. Let's go ahead and cancel this. Exit. So exit. Yes. Enter. There we go. So now if we go back to it, sudo nano 443. That's how we want it. Now we need to go ahead and restart this again. I'm sorry for that. I forgot that you have to add a port number, and the port number that you need to add there is 443. And then if you go back over here, and if you go to now https colon / 10.1.1.6, it should take you there. And there we go. And the way that you log in over here is by doing root username and root password, the same way that you log in to the CLI. So on the next video, we are going to configure a static NAT. So we're going to add over here IP address 10.1.1.3, and when you reach 20.1.1.3, I'm sorry, when you reach 20.1.1.3, it is going to translate it to 10.1.1.6. So people from the outside are able to reach this private IP address by adding it to a public IP address. So in this video, we are going to continue with where we left off. So we configure this Linux device with 10.1.1.6. We also added or removed the port number 10,000, and we added 443. And we were able to access 10.1.1.6 from this Windows device. So if you go to this Windows device, if you guys remember, we went to HTTPS 10.1.1.6, and there we go. So we are able to get there from the private IP address. But now what we want to do is that we want to get to this server from a public IP address, so anybody from the outside is able to get in, right? It's basically how everybody does it. So 20.1.1.3, that's what we're going to add. We are going to say that it is static. Okay, so what we want to do is we want to go ahead and create an object, and we want to translate that object, which is 10.1.1.6, into this static NAT at 20.1.1.3, and we also want to create some security policies on this checkpoint gateway number 1. So let's go ahead to this Windows device and access the management server, so we can configure the checkpoint number 1 via the Smart Console. So we are going to go to security policies first. And first, we need to go ahead and specify because we haven't specified an inbound policy. So all the policies that we have right now, if you can see, they're basically all going out. So they're basically going from the host to another location, from inside to outside. So now we need to go ahead and add a new one. So we're going to add it above the cleanup rule. It's going to be a new section above, and it's going to be an inbound policy. Inbound policy. And we are going to add a new rule below. And this rule is going to just be called, I guess, inbound traffic. Let's go ahead and call it inbound traffic. So this inbound traffic, we want it to come from any source. Any source meaning that anybody from outside, I'm going to allow it to go into this Linux device. Okay, and where is it going? Well, the destination that is going to be a new host, and this host is going to be called, let's just call it Linux server. IP address of the machine 10.1.1.6. Right now we want to do a NAT. So you're going to go to the NAT. We are going to add automatic address translation rules. So the hide NAT is basically dynamic NAT. Remember that for the exam. Static NAT is one-to-one mapping. Hide NAT is dynamic mapping, which is one-to-many. Static is one-to-one. So what do you want this to be translated to 20.1.1.3? Right, that's the one that we had over here. Yep, 20.1.1.3. And that's all she wrote. So we are going to add over here. So now, what services and applications do we want to be allowed on this Linux server? Well, I want to allow HTTPS. That's it. So we are going to go HTTPS. Add it. What do we want to do? We want to accept that traffic. Do we want to log in? Of course we do. Yep, of course we do. So anything that tries to go to 10.1.1.6, aka 20.1.1.3, it is going to be allowed in this policy for the gateway number 1. Okay, great. So now let's go ahead and take a look at policy gateway number 2. Now we can see from inside to outside, HTTP, HTTPS. So that should be good. Let me make sure that this is good. So this one over here says any. Why don't we just say, so it doesn't messes up my one below. So if it is, yeah, HTTP, yep, no, let's just leave it like that. Any, that's fine, because we are not going to any of these destinations. So it's going to fail, and then it's going to go to traffic, and then no, and then it's going to go over here. Yep, so it should allow it on this rule right here, which we have not tracking it. So let's go ahead and select that. Are we not oh, let me go ahead and tap down. Yeah, we are tracking it, so that's good. So we should be hitting this rule right here, 2.1, whenever we go out from that from this checkpoint gateway number 2. We should be able to be hitting 2.1, and whenever we are coming in to take a look at Linux, to this Linux server, we should be hitting this checkpoint gateway number 1, and it should be the inbound traffic. Any Linux source, HTTPS, accepted. Let's go ahead and publish our changes. And then we are going to install it, of course. Come on, come on. If you can do it, you can make it. Oh, did I only do publish? Okay, let's go ahead and install it. I'm gonna use to just hitting install and adding it from there. So we are going to install the policy for checkpoint gateway number 1. I don't think we need to do policy gateway number 2. I don't think we did anything there, but just because we are going to add it there too. So now the policy has been installed, policy gateway number 1. So now we can go ahead and test this. So we are going to go to this Windows device, and we are going to try to access Linux server at 20.1.1.3. So we are going to go to this Windows device. We are going to already create a link over here, or a bookmark, yep, a link, whatever you want to call it. So we are going to open that bad boy, and This one is going to take us to 20.1.1.3, and you can see right now that we got to that server 20.1.1.3. So static NAT one-to-one translation is working. You can see the username, root, password, root, and this is from this other Windows device over here. We were able to traverse all the way over here to static 20.1.1.3. So it is working the way we wanted it. So that's great. Static one-to-one translation, one-to-one mapping. It is working. So now if we want to take a look at the logs, we can go to this Windows device and we can go ahead and go to logs and monitor. Let's go ahead and take a look at those rules. And let's see what we find. You can see right here, you're going to see a lot of traffic over here. So let's go ahead and just go to security policies. And if we go to the one that it should be working on, which is the inbound traffic, and you go to logs, and you can pull this up, you can see it right here at the source that it's coming from. So remember we're doing, every time we go outside, right, from this IP address, we are taking dynamic NAT, which is one to many mapping. So 20.1.1.4, right? So that's why it is saying, let's go over here. So that's why it is saying that it is coming from 20.1.1.4, because every time we go out, we are NATing. So we're taking 20.1.1.4 to go out to the internet. So 20.1.1.4, destination 20.1.1.3, you can see HTTPS, TCP 443. And if you double click on it and you open it, you can see all that traffic. Did it crash? No. Let's go ahead and see it again. There we go. And also you can see it over here, where it's coming from. The source zone, external 20.1.1.3, destination, the source 20.1.1.4. You can see the service is HTTPS, TCP 443. And you can see that we're doing some NAT, so NAT network address translation. So it is basically going from 20.1.1.3. It is being translated into NAT, static NAT, to go to 10.1.1.6. You can see NAT rule is number 2. And you can see the NAT additional rule. So that is great. So it is working the way we wanted it. And if we go to NAT, you are going to see that NAT entry, that static NAT entry over here. So there we go. You can see the original is 10.1.1.6. The destination is any, original service is any, translated sources is Linux over here. And then you can see when it's coming from any to this, you can see the little S, which means static NAT. So we are doing static NAT. How you guys are doing? In this video, we are going to go over DMZ. As you can see right now, what I did was I unplugged the Linux server from the switch and I plug it into Ethernet 2 at the CheckPoint gateway number 1 firewall. And and the reason why I did this is because this Linux device was in this network, and we created a rule or security policies where anybody from the outside is able to get in there, and when they get in here, they are getting into the inside zone, and we don't want people to get into the inside zone. We don't want to share. We don't want to have anybody from the outside to come in here and be in the same network, basically, because this Linux device was in the same network as everybody else in this inside network. And what happens is, if this server somehow gets compromised, then a hacker will be able to gain access to other Windows device or even the management server. So therefore, we want to create a new security zone, and we want to create more security policies, because the DMZ is basically a physical we are doing a physical by plugging this in into another Ethernet. So it's a physical or logical subnetwork that contains and exposes an organization's external facing services to an untrust networks such as the internet. So since people from the internet were able to get in here and go into the inside, you don't want that. You don't want to expose that. So we are just basically going to physically we are separating from the inside, and then logically we are going to separate it by basically creating another network. So now they're not going to be they're going to be in a different network. And now if a hacker gets in here, they won't be able to get anywhere else, because the only thing that's going to get compromised is the Linux server. So we're also going to add IP address 192.168.1.6 for the server, and the IP address for the checkpoint is going to be 192.168.1.3. That's how we are going to keep it. So you have to, whenever you turn it off and turn it back on, this Linux server, you have to reconfigure that IP address. So we want to go to ifconfig ENS3 IP address 192.168.1.1 or the 1.6 net mask 255.255.255.0. Bring it up. Then we're going to do routes at default gateway or GW 192.168.1.3. There we go. So that is great. So now we need to go ahead and go into this checkpoint firewall. We need to configure that IP address of 192.168.1.3. And we also need to create a zone and all of that good stuff that we have done, and then that we should be able that we should know how to do. So let's go ahead and go to that checkpoint firewall. So we are going to go from this computer to the checkpoint firewall, but we are going to access the web GUI. So we want to go to HTTPS 10.1.1.3. Log in with your account. I have my password saved. Now we want to go to IPv4 network interfaces, and we want to go to Ethernet 2. I believe that's where it is plugged in. Yep, Ethernet 2. We want to enable it. IPv4 address is going to be 192.168.1.3. Subnet mask 255.255.255. Well, 255.255.255.0. Press OK. This interface should come up. Great. So that is done. So now we need to go into the Smart Console. And the first thing is that I want to go to policies. So the first policy that I want to do, inbound policies. What I want to do for this inbound policy is that I want to go ahead and change it to inbound or to DMZ. Inbound to DMZ. That's what we're going to call it. So, well, let's say outside. We are going to separate this. So we are going to do outside to DMZ. We are also going to be adding another one below. So this one is going to be not a section. We don't want a section. We want a new rule. Yes, delete that section. This new rule is going to be below. And we are going to call this inside, because we want the inside to DMZ. So the outside to DMZ could be any source, but the inside I want to specify the 10.1.1.0 network. 10.1.1.0. Do I have a network for that? I do not. So let's go ahead and create a new one. It's going to be a network. We are going to call this inside network. So we're going to create a new network object. IP address 10.1.1.0. Net mask 255.255.0. So I'm creating an object for this network over here, and I want to add that network to be allowed to go from here to inside here, and the outside from here, any source, so any address doesn't matter, to in here. So I want to separate the two. We don't need to do NAT. There we go. So inside network 10.1.1.0 to the source of Linux device, we can add the Linux server, which we have to edit that. We need to edit that IP address, because so if we go to, let's go ahead and just go to objects, network objects, host, Linux server. Since that IP address changed, we want to go ahead and do 192.168.1.6. So that should be edited on everywhere else. 192.168.1.6. There we go. So now we want to just allow HTTPS, because that's all we need to do, HTTPS. We're going to add it. We're going to accept. We're going to log it, and there we go. So now we have two rules. One that we named outside to DMZ. This one is coming from anybody outside, from the outside network. So let's see. So what we could do is basically, before we do that, let's go ahead and do with zones. Zones is going to be a lot better, because we don't need to then do IP addresses. So let's go ahead and go to tab left. We want to go to global properties, and we're going to add Ethernet 2 to the, let's see, no, let's go ahead and go to gateways. Double click on checkpoint gateway number 1, which is this one right here. We want to go to network management. We want to go ahead and get the interfaces, so we can get the latest interface that we just added. There we go, accept it. You can see 192.168.1.3. And there we go. So this one, we need to go ahead and add it to DMZ. Modify. So we're going to add a new security zone, just like we did before. Let's go ahead and just create a new one. That's fine. DMZ. Okay. And okay. 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 So that's going to be better if we go now to security policies, and we do this based, instead of IP addresses, I want to do it based on zones. So coming from outside to DMZ. So in here, what we could do is we can just add the outside zone. Boom. Then we can do, instead of Linux device, Linux server, well, we can keep Linux server, because it has that IP address 192.168.1.6. Right, so outside to DMZ, that should be fine. So let's go ahead and just add, we can go ahead and add DMZ2. And then from inside to DMZ, we can just go ahead and remove that, because we don't really need to do any NAT and the destination DMZ, not DMS, DMZ. Let's go ahead and add it. Great. We are going to allow HTTPS, accept and accept, and we are going to log that traffic. So now we can see that coming from the outside to DMZ, the source is outside, destination either the Linux server or the DMZ zone should be good. From the inside, we can just go from the inside network. But I don't want to add the inside network. I want to remove, it's the same, but I want to keep it more zone based. So let's go ahead and add over here inside zone. There we go. And DMZ zone, HTTPS, and we're going to allow that traffic. So when we're coming from the outside, we should be able to, so coming from out here, we should be able to access 192.168.1.6.20.1.1.3. So all of that should be good. Let's go ahead and install this policy. Publish and install. And then after that, it should ask us to install it and where we want to install it. And we are going to say that we want to install it in, we want to install the gateway policy, the policy gateway number 1, because that's the one that we basically configure everything. The security policy has been installed, and we only need to install it on the policy gateway number 1. And if you want to verify which one you install first or last, if you go down here, you can see the latest one. It was policy gateway number 1, and if you press this over here, you can see which one was the one that you installed, and if you need to install the other one, then you know which one you need to install. But since we only need to do it for policy _ gateway number 1, then you should be good to just go ahead and test this. So the way that we're going to test this is by, first we are going to go into this Windows device over here, and we're going to access HTTPS on 20.1.1.3. So let's go ahead and go to over here. I already have a link, so I don't need to keep typing it, wasting you guys time. And there we go. We were able to get a 20.1.1.3. Let's go ahead and continue to this web page and login root, password root, and there we go. We are able to get there. So now, since we can see that this rule, the one that should apply for this rule, it should be from outside to DMZ. So we can verify this by going into this outside to DMZ policy, and if we go ahead and click on the logs, let's go ahead and refresh this, which you see some fresh traffic over here coming from 20.1.1.4, which we are doing dynamic NAT over there, and the destination is 20.1.1.3 at TCP HTTPS TCP port 443. If you double click on it, you can see everything that's going on. You can see that we're doing NAT on 192.168.1.6. So everything is looking really good. All right, so that is great. Now let's go ahead and try it from the inside to DMZ. You can see we don't have any logs. Let's see what happens. So let's go ahead and go to this Windows device. Well, the same Windows device as a smart console. I forgot about that. And we want to go into, what if we go, I think if we go to 192.168.1.6 should be good. That 1.6. And there we go. You can access via the local IP address. That is fine. And there we go. So we got there, root and root, and that should let you log in. If you go to the other device, you already are logged in. You can see the system information, and you can see it from over here as well. So that is great. We were able to separate our Linux device so we do not get hacked. Also, let's go ahead and add a cool label over here so we can specify what the zone this is. So this is DMZ. So that is what DMZ is all about. Thank you guys for watching.